We already talked about the heat necessary to go through a temperature change, but there's some times when an object takes in heat and still does not change temperature, and that occurs when we go through a phase change. So if ice melts into water, the ice stays at the same temperature while it's melting in water. So during a phase change, the temperature stays the same. During a phase change, the temperature stays the same. So instead, what we want to talk about is an object's resistance to change its phase, and we refer to that as latent heat, resistance to change its phase. There's two types of latent heat that we can refer to. There's a latent heat of fusion, which is the symbol L sub F, and that is when we go from a solid to a liquid, like ice into water, which we call melting. But it's also when we go from a liquid to a solid, like water into ice, which we call freezing. Besides latent heat of fusion, there's also latent heat of vaporization. That's when we go from a liquid into a gas, such as when we boil water. Or it's also when we go from a gas to a liquid, such as when there's condensation due to steam going back into water. Now what we have here is different materials have different latent heats. Let's look at water, or H2O I should be saying instead. The latent heat of fusion of H2O is 333,000 joules per kilogram. That means that for every kilogram of ice I have, it takes 333,000 joules to melt it. So if I have 2 kilograms of ice, it would take 666,000 joules to melt. If I have 3 kilograms of ice, it would take 999 joules of heat to melt, and so forth. We also have latent heat of vaporization if we're going from water into steam, and that is 2,260,000 joules per kilogram. So if I want to change 1 kilogram of water into steam, it'll take 2,260,000 joules of heat to do so. You'll notice that's a lot larger than the latent heat of fusion. It takes a lot more energy to turn something into a gas than it takes to turn something into a liquid. And the reason is because when you turn into a gas, the particles are actually spreading out and defying gravity. And so we need to give it enough energy to fly straight up into the air and spread out and take up the entire container. So it takes a lot more energy to vaporize than it does for melting. Now latent heat, to get the value for the heat necessary using latent heat, you saw that we simply take that value for latent heat and multiply by the mass. So here's our equation. Q for heat is equal to M for mass times L for latent heat, whether it's fusion or vaporization. Now this latent heat value can be positive or negative. It is positive if heat is added, such as going from a solid to a liquid or a liquid to a gas. So we refer to this when heat is added, we refer to this as exothermic, or endothermic, sorry. So it is endothermic, endo meaning enter, if the heat is added or positive. We have negative latent heat if heat is removed. In other words, going from a gas to a liquid or a liquid to a solid. And we refer to this process as exothermic. Heat exits the substance, and so it is exothermic if heat is removed. So again, these values can be positive or negative, depending on if it is endothermic or exothermic, depending on if heat is added or removed. The units we had seen before, it's joules per kilogram. So again, it's telling us how many joules of heat is necessary to change 1 kilogram of a substance.